I teach Empowering Hawaii's Teachers in Technology Conference, sponsored by the Augustine Educational Foundation and Sacred Hearts Academy, Honolulu. My name is Melissa Thatch, and I'll be facilitating this session. We are so honored to have Chayanee Brooks join us today to share her expertise through a 90-minute presentation named 10 Ways to Promote Student Success Using Brain Development Studies. Please be aware that we are recording this session. If you don't want to be recorded, you may consider turning off your camera during the session or viewing the recording afterwards. The recording will be made available on YouTube and shared on iTeach 808's website a week after this event. Without further ado, I will turn it over to Chayanee.
Thank you so much, Melissa. I'm so happy to be with you guys today to share some of the things that I've learned through my program. But first of all, I would like to acknowledge our sponsors of this event. And our sponsors are iTeach 808, Augustine Educational Foundation, and Sacred Hearts Academy. Thank you so much for providing this opportunity for teachers in Hawaii for free. First, I just want to kind of tell you the layout of this presentation. In the first half of our time together, you will learn about basic anatomical structure of the brain and its function, also development of the brain from embryonic stage to mature stage, and the concept of executive functions as well. You might wonder what executive functions are. I will explain it to you later on, but I can just tell you briefly right now that executive functions refer to mental set of skills and cognitive processes that is important for learning and success. And so the second half of our time together will be workshop time, where you can get to be hands-on and learn how to use the technology tools such as Google Slide to design activities and games that can enhance your students' cognitive flexibility and cognitive ability, as well as executive functions. If you have any questions during the time that I present, please put your questions in the chat, and then Melissa will help me monitor the chat so I can answer them in the Q&A session in the end. But if you really want to ask your question right away, you can, of course, unmute and then ask for any clarification of any terms or concepts. Okay, next up is some information about me. My name is Chayanee Brooks, and I am a high school English teacher at Ka'u High and Pahala Elementary School on the Big Island. I am currently in a PhD program in neuroscience, and I am so fascinated by cognitive neuroscience in particular, and how the mind, the brain, and the behavior work together. And I think when I teach, I keep thinking that there might be more explicit explanations beyond psychology or beyond what I've learned through my teaching program, and that's how I chose to be in neuroscience program. In this session, I am going to share with you some of the neat things that I am learning that will guide my teaching and hopefully help yours too. If you have any questions so far right now about me, you can, of course, put it in the chat. But if not, we will move on to the definition of executive functions. So some of you might have heard of executive functions before, but what are they exactly, right? So again, just like I mentioned earlier, that executive functions refer to mental set of skills important for learning and success. And there are 9 core skills that you see on the slide right here, which include inhibition or inhibitory control, working memory, cognitive flexibility, emotional control, focused attention, self-monitoring, initiation, planning and organization, and then goal-directed persistence. Okay, now for our presentation today, we will focus on the 3 main skills of executive functions, which include working memory, inhibitory control, and then cognitive flexibility. Okay, that you see on the slide right here. Okay, so now you will see these two images, right, of the brain. The images of the brain that you see here on the left is the um, outside side of the brain, and then the one on the right here is sagittal cross section view of the brain. Okay, and I will explain each part of the brain to you right now. So as you can see, the color code legend right here, the blue represent working memory, and if you look on the image, the sagittal cross section on the right, that is the area of our brain where is responsible for working memory. And that part of the brain is medial orbital frontal prefrontal cortex. So PFC stand for prefrontal cortex, which is the front part of your brain, just right behind your forehead, right there. And then the orange here, you can see on the right image of the brain, it's in the middle, and that is the area that is called basal ganglia. Okay, so basal ganglia is responsible for our body movement. Okay, when in patient with Parkinson's disease, they have dysfunction or maybe some lesion in the basal ganglia area. And then the orange color right here on the left side of the image, here you will see the area that is called inferior frontal gyrus, as well as anterior insula. And these orangey areas are responsible for inhibitory control. Okay, and I will explain next what these mean, and I will also give you some example of how to assess these skills in your students as well. Now the purple color right here represent reasoning, and the area in our brain that is responsible for that is the rostral prefrontal cortex. Okay, that area right there. And then the green color here, maintenance of information in working memory and task switching or cognitive flexibility, that is the ventral lateral. VL stand for ventral lateral prefrontal cortex. And that part is regulating maintenance of information in working memory, as well as task switching or cognitive flexibility. And then lastly, right here, the dark blue area represent manipulation of information in working memory and planning. Okay, and this area correspond to the dorsal lateral prefrontal cortex part of the brain right there. Okay, now just like I mentioned earlier, that executive functions are how the brain uses natural capacity to set and manage and attain goals, right? We will further take a look at how executive function can be developed early in life to promote competence across life and to determine the extent to which plasticity can be beneficially modified through learning. And that is something that you can use with your students, definitely. So on the description here that you see on my screen, you will see working memory, right? One of the main core skill of executive function. And working memory refer to not only recalling information, but also the ability to hold information and also manipulate the information in mind. Okay, and we'll see some example in the next slide. Secondly is inhibitory control or inhibition. And what it means is that it is the ability to act purposefully despite distraction. So if we have inhibitory control, we would be able to stop our action if it's not desirable, or we would be able to pursue the action that would help us attain goals. Okay. And then lastly here is cognitive flexibility, which is the ability to switch between ways of thinking. Okay. And I've heard people refer to this cognitive flexibility as the ability to think outside of the box. Okay, and then we'll explore this further in the next slide as well. These three cognitive process work together. Okay, they cannot just work alone. Even though they will be developed during different developmental level, okay, the cognitive flexibility will come later in life because of the nature of how our brain develop. The high brain first, mid brain second, and then the forebrain last, right? But we can help our student to have that early development through training, and we of course can use technology to help them with that as well. Okay, so this slide that you see on my screen is the embryonic brain. On the far left right here, you see that there are 3 vesicles, right? So this is the earliest development of the brain. And then when we move to the right, and the far right would be a more mature version of the brain. So the brain starts from just a neural plate, and then they start fold up to be like a neural tube, and then that tube will further develop to be CNS or central nervous system, and then the brain and spinal cord, right? Those including the central nervous system, and then peripheral nervous system, and so on. But I want you to just focus on the development of the brain right here from its earliest stage. So the 3 vesicle stage, you'll see that there are 3 parts, right? The prosencephalon or the forebrain, mesencephalon on the midbrain, and then the rhombencephalon or the hindbrain. Now, the reason why I put this slide in here is to show you the order of development of the brain. The hindbrain in the back, that is responsible for, simple vital signs and things like that will develop first. And then the forebrain will develop last. And the forebrain, if you recall the last slide, it's the area that is responsible for executive functions, right? And normally we can keep developing that area of the brain starting earlier, as early as like preschool until 25 years old. I will talk more on that. But right now, I just want you to focus on just kind of a different part of the brain and how they develop to become a more mature stage. So after the 3 brain vesicle stage, you see the 5 vesicle stage right here. And you can see the development between the 3 stage and the 5 stage. From prosencephalon will become telencephalon, and then diencephalon, right? Midbrain will stay the same throughout, if you can see. And then the hindbrain or rhombencephalon will develop to become metencephalon and then myelencephalon. This is the middle stage or 5 vesicle stage of the brain. And then the most mature brain version is the far right here on my screen. And now you will start to see the more familiar terms, right, of the brain. From telencephalon, now in a mature stage, you have cerebrum, which is again the big brain or the executive function area, the front part of the brain, okay? And then as well as eye cup, tiny one right there, and then diencephalon will develop to become thalamus, hypothalamus, and epithalamus. Midbrain will stay the same, right, from mesencephalon. And then metencephalon will develop to become pons and cerebellum, which is again in the back part of your head right here. And it's responsible for movement, right, body movement. And then medulla oblongata right here as well. Responsible for vital signs such as blood pressure, body temperature, and so on. Okay, so again, the key idea of this slide is for you to see the development of the brain and see that the forebrain or the big brain area where executive functions will develop last. Okay. All right, the next slide right here. This is what the basic anatomy of the brain looks like. Okay. I want you to pay attention to the right image right here, the sagittal section of the brain, right? You see prefrontal cortex. Okay, now you know the prefrontal cortex is responsible for executive function. And then pituitary gland for responsible for hormone secretion. Amygdala, you probably have heard of that a lot. That is the area that is responsible for emotional arousal. And then brain stem, responsible for vital sign. Hypothalamus, it's the area that relays sensory motor input or stimuli. And then cerebellum, body movement. And lastly, right here, I want you to pay attention as well. This is the most important for, I cannot say the most, but one of the most important area for learning and memory, and that is hippocampus. Okay, so hippocampus in Greek, it means seahorse. The shape looks kind of similar to seahorse, but anyway, in learning and memory, every time when we learn something new, the information will be stored in hippocampus first. And then through memory consolidation and through practicing and things like that over time, the information, which is considered short-term memory in hippocampus, will transfer to be in different part of the brain. Okay. And I didn't mention any information about different part of the brain earlier, but I think it's the important idea for you to keep in mind so that you would understand the information that I present to you in the next slide. So now at least you know the prefrontal cortex. Okay, so the prefrontal cortex is part of your frontal lobe of the brain. In some textbook, they say there are 4 lobes of the brain, but in some they say 5 and in some 6. But I'm just going to tell you all of them. So the front part is frontal lobe. Okay, and the one right here is parietal lobe. And the parietal lobe is the area that is responsible for sensory, motor, and somatosensory stimulus. Okay, it's how you sense things from peripherals or from your extremity will transfer back to here, as well as how your CNS send information through your limbs and extremities as well. The third lobe, right? It's in the back right here, and that is called occipital lobe. And that part is responsible for your visual input. Okay. And then the fourth lobe is the area just right here next to your ear, and that is temporal lobe. And it's easy to remember the function because the temporal lobe, like right next to your ear, right, that is responsible for auditory input. Okay, and then some say that if you open up all these lobes in the cortical area, inside the subcortical area, inside the brain, you would see insular lobe, which is responsible for feeling, like visceral feeling and feeling of disgust and love and things like that, empathy. And then that is the area close to amygdala as well. Right? And some people say limbic as a lobe as well, and limbic system that include amygdala as well as hippocampus. Okay, so knowing all these different part of the brain and how it each part get input from different type of stimuli, right? I want you to now transfer your attention to the left picture here. The left image here, you see the fMRI images that show different parts of the brain are activated when the participants do different things. So for example, when you hear words, again, that's the temporal lobe, right? You will see this part of the brain is being activated. And then when you see words, the occipital lobe, okay, which is responsible for visual input, that will be activated. When you speak, that's the area somewhat between the parietal lobe and the frontal lobe, because the parietal lobe is responsible for motor and sensory input or output as well, right? And then lastly, the one on the the bottom right area of the brain, that's the frontal lobe. And that is the area that is called a Broca's area, because the guys who found out this area was, his name was Broca. And then this area is responsible for generating words. Okay, so what is the implication as a teacher? Now, knowing this, okay, you might want to remember this image really well, because their brain, your student's brain, will be activated in different places, right? When they engage in different type of tasks or different type of inputs, when they hear things, when they see things, when they read, when they write things, they will have tendency to have a better outcome in learning. And that's the implication for us as teachers. Okay. Now, next slide here, it's a lot of words, but I'm just gonna summarize what is important here on this slide. So as we learn more about executive functions, it's clear, right, that some of us might not realize, or we might not use all these insights in everything that we do in planning pedagogical instruction. Even some educational strategies might be misguided as well, such as learning style. That's like, if you think about it, learning style is only activating one part of the brain. And we don't want that. And knowing the information from the last slide this slide, you would know that we want to activate as many parts of the brain as possible, so that the students would be able to remember it better. Okay. And the last sentence right here that I want you to take a look is for you to remember that it's possible to improve the executive functions of children or students with deficits through classroom strategies and support. And that's something that I'm gonna show you next, and you can get to try some of the activities out as well. That'll be fun. Okay, the next slide here, it's the graphic representation of executive functions by Adele Diamond, and she is a really well-known person for executive functions. She's like a mother of executive functions. In here, you would see the main executive function core skill, right? Working memory, inhibitory control, and then cognitive flexibility. Now, let's take a look at each one at a time. So working memory here, if you recall, it's not only the ability to recall information, but the ability to also manipulate the information in one's mind. Okay, and it can be verbal type of memory, or it can also be visual and spatial working memory. And then on the right here, inhibitory control or inhibition, you will see that it's not only controlling our thoughts on memory, that's cognitive inhibition, but it is also the ability to control our action. So it can be from within, and it can be behavior type of control as well. And those are the subset of inhibitory control. And you can see that there's a link between working memory and inhibitory control. Okay, these two skills work hand in hand. And that is because if someone has good working memory, they would know what they should do and what they shouldn't do. Okay, and they would remember that, oh, this is the action that I should inhibit, and this is the action that I should go forward. Okay, so that is why working memory is important for inhibitory control. Now, at the same time, inhibitory control, if someone has good inhibitory control, they would have good working memory. And the reason is because if they can control their mind and if they can control their body to focus attention, they would be able to learn better and remember things better. Okay, so these two skills are really key to learning, and they go together. they support each other. And then next, I want you to take a look at self-regulation here. Now, one might wonder, what is the difference between self-regulation and inhibitory control? So self-regulation is like a long-term version of inhibitory control because it requires you to have so many occurrence of things that you have to inhibit, like things that you have to stop doing in order that you can achieve your goal. Okay, so self-regulation is a long-term type of goal when compared to inhibitory control. And then the last core skill of executive function here is cognitive flexibility. And cognitive flexibility is, just like I mentioned earlier, the ability to think outside of the box. Okay, and for this one, it will be involved in creativity and also theory of mind. Now, what is theory of mind? Theory of mind is the ability to think from other people's point of view or perspective. And little kids would have a hard time on this. But again, this skill can be developed. It will develop over time when their prefrontal cortex start to become more mature, or it can also be developed earlier if we use some of the trainings and the activities that I am going to show you in this session. And then you will see that all these core skills will point down towards higher level executive functions, which include reasoning, problem solving, and then planning. And this one we're not going to talk about, but as you can see that there are also something that we want our students to have, right, in order to be successful in learning. And so when I think about this, I think about all the students population that I have, and some students population, the maybe ADHD, you might want to bear in mind that they might have some issue with working memory, or maybe inhibitory control, or maybe both. Okay, and knowing this, not only students with disability, but also students who are still developing. Even though you have high school students, you have to keep in mind that their brain is still developing, and they can still keep developing until 25 years old, according to research. So if you help them, guide them, and work with them on these skills, that will be, goal as a teacher. All right, now next slide here, I did some literature review on neurodevelopmental strategies and theories on executive function, or EF, executive functions. And the key information that I would like us to take a look at would be the second bullet point right here. So the second bullet point says developmental change in children's DCCS. DCCS stand for dimensional change card sort. And that is an assessment that we use to assess cognitive flexibility in children. Okay, and you guys are going to get to try that out too and see what it looks like. Okay, so developmental change in children's DCCS, again, dimensional change card sort, performance is attributable to an increase in strength of connectivity between the frontal and the object representation system. Strong connectivity enables the frontal system to prime neural populations tuned to the post-switch dimension more strongly, overcoming the stream of memories required by sorting during the pre-switch phase of the task. Okay, it looks like a lot of work, but the key details here is that it is going to be more complex if you add more kind of condition in the pre-switch and post-switch. So I can just explain it to you briefly right now, but you will get to actually watch it in a video clip where the experimenter used this type of task to assess students' cognitive flexibility. But the card sort that I mentioned looks like this. Okay, so children will be given different cards, and one would be the blue boat, and then another will be the red boat and red rabbit, as well as blue rabbit. So they in the pre-switch, they're going to be told that, okay, you're going to have to sort the card based on color. Okay? And the kids would have to, if they see this boat, if the experimenter show them this boat, and if the kids got this one, they're going to have to put it together with this, not this, because we are sorting the card based on color, right? That's the pre-switch. And post-switch, meaning that now the experimenter will tell the kid to, okay, now we're going to start sorting the card based on shape. So now the kids will have to sort the card based on shape. So even though they see the different color, but that doesn't matter because it's the same shape. Okay, you're going to see this in the video clip, and it will give you a more clearer picture of what it looks like. And the key here is that it is more complex, right? When you keep adding or changing the condition of your task. And what experimenter found was that the younger the kids, they tend to not be able to do it successfully if you keep changing the condition. And that is the cognitive flexibility, the ability to change rules based on the situation, based on the condition. Okay. All right, now we get to see the image of the brain again. And I think so far we have talked about different part of the brain, right? Let's review that a little bit. So the back part right here, occipital lobe, responsible for visual input. The middle here, parietal lobe, responsible for somatosensory input and motor sensory stimuli. And then the prefrontal cortex right here is the part where executive function is, like the function is to control executive function. And then the temporal lobe, auditory, right? And inside the brain is the insular lobe, which is responsible for feeling love, disgust, and so on and so forth. For this one, I would like you to pay attention to the hot and cool or cold executive functions. So we talk about the main type of executive function, right? Being cognitive flexibility, integrity control, and working memory. Now for this one, researcher found that there are two types of executive function. And the one that we refer to as core or core executive function are these skills, sub-skills. Okay, planning, cognitive flexibility, working memory, initiation, suppression, concept formation. And if you see the core compared to the hot on the right here, you can see that the hot is more social emotion, right? And then the cold is more like cognitive ability, cognition. Okay. And in the image here that you see of the brain, the hot area is in this area, the orbitofrontal prefrontal cortex right there, ventrolateral prefrontal cortex. And then that's the main one, right, we talked about earlier. These are something that is responsible for social emotion and thinking, as well as the amygdala that you see right here, thalamus, striatum. And then the front part right here is the core co-executive function, which refer to rostral prefrontal cortex and then dorsolateral prefrontal cortex. And this section of the brain in the frontal lobe will be developed later. That's why little kids could not do some of the cognitive tasks successfully when compared to older kids or adults. It's because they're still developing those area of the brain. Okay, now we're going to take a look further at working memory and the assessment as well as intervention from research that you can actually apply in your classroom. So for working memory, the type of assessment that we use, we call span task. And the span task can be digit span task or missing span task, and today we're going to get to try the missing span task in the next slide. But just remember that those are the type of tasks that we use to assess working memory as well as design intervention for working memory. Okay, so this is just the detail about the function of dorsolateral prefrontal cortex that we mentioned that it involved in executive function, especially working memory, right? In the functional MRI, they found that participants who are younger might have a more difficult time when it comes to the task that is more complex. Okay. I know it's kind of a lot of information, so you can take a look later. I put it here, a lot of them, because you guys can kind of review it later on. And I think Melissa can put the PDF in the chat if you guys want to refer back to that. Because I know it's like tons of information, but I think it's really useful and you can apply it directly. Okay, so for this slide, I just want you to focus attention to the last sentence right here. The result raised the possibility that children rely on ventral processes involved in object processing rather than dorsal processes involved in spatial processing to perform the memory-guided saccade task, which in turn might yield poorer performance. So the explanation behind why younger kids could not perform as well as older kids, it's because of the limitation of those areas that's still developing. Okay. So that's why we have to design a different type of assessment, a different type of intervention when we have different type of population, like the, younger kids, elementary, middle school, or high school. Okay, and then the activity that we use in working memory, it's in the frontal region of the brain. Okay, and if you recall what I said, is that it's not the only area that is activated because it depends on the type of stimuli. If they were given the type of stimuli where it's a visual, they are probably going to use the occipital cortex as well, which is responsible for vision. Okay, so different part of the brain will be activated depending on the type of task and the type of stimuli. Now, this slide, I would like to show you an alternative assessment. So apart from using fMRI, researchers use FNIR, or functional near infrared spectroscopy, to see the activity of the brain in different region while children are performing different kind of tasks. And what you see here is FNIR, okay, or this functional near infrared spectroscopy. So you will see the cap, and then that cap will connect to the screen, and you will see the wave and the information of the activity of the brain while children perform tasks. And the reason why some researchers prefer this strategy is because there are some limitation when it comes to functional MRI, because functional MRI machine require kids to have to lay still in a really narrow tunnel, right? That might, and there might be some loud noise during that time to perform tasks, and they might get anxious. The FNIR will allow participants to sit on their parents' or guardians' lap while performing tasks. Okay, so that is probably more appropriate when it comes to younger participants. And then the information here, they found that 3-year-old children show greater left parietal and right frontal response during the encoding phase of memory array than during the later comparison phase. And then this pattern of activity was associated with poorer performance in the change detection task. It's kind of like the summary of what we talked about earlier, that the different part of the brain would be activated, right? And for younger participants, they might not have the mature part of the brain in the frontal cortex to take care of that task yet. Therefore, they rely on other part of the brain to do that task, and that might not be as effective as using the brain area where adults use. Okay, so now you get to see inhibitory control type of assessment by Adele Diamond right here, the mother of executive functions, right? Go task, that's something that we also use for children, and Stroop task is actually something I want you guys to try today. That's for adult to assess inhibitory control. And then the day and night task is the task for children. And what you're going to see here in the video clip is the day and night task. So let's take a look.
A child is shown a picture of the sun and has to say night. And when shown a picture of the moon, he should say day.
What do you say when you see this? Yes. What do you say when you see this?
The little boy is going and making mistakes.
Okay. So that was how it looks like. But what I get from it is that processing time is key, and having the children or students pause and think about the answer before telling it, right? So wait time, I think that's what we kind of use as teachers. Alrighty, okay. So this one is go, no go task, which is also used for assessing children's executive function in inhibitory control. Okay, and this can be done through a program like this online, where participants will see yellow or blue. Okay, and the condition is that if they see yellow square appears on the screen, they're going to have to press P key on the keyboard. If they see a blue square appears, they do not press anything. So this is to assess the inhibition or inhibitory control for children. Okay. Now, what you see up here are different part of the brain, and they're all kind of somewhat color coded in different color. And it's a fMRI image where you can see dorsolateral prefrontal cortex, which is, again, this area is important for executive function. Okay, so the frontal part just behind your forehead right there. And then we see amygdala, emotional stress, arousal and things, and then anterior cingulate cortex, as well as hippocampus, which is very important for learning and memory, because everything that you learn new or that children learn would be stored in hippocampus first. So in some case, for patient with Alzheimer's disease and things like that, the hippocampus would be attacked first by the disease. And that is why they cannot remember anything that just happened, but they have long-term memory, because those memories are stored in different part of the brain. And there are different type of memory, for example, decorative memory and non-decorative memory. The decorative memory is like a kind of direct things that you learn that remember, but non-decorative would be the skills that you've learned, such as learn how to ride a bicycle. And those will be stored in different part of the brain, even in the cerebellum, where it's controlling the body movement, right? Now, the implication for this slide is that connectivity, as you see, the brain communicate with each other all the time among different regions. So younger participant or younger children might not be able to use all part of the brain because it's still developing, right? Especially in the frontal lobe or prefrontal cortex. So you see here that connectivity within frontal and parietal region, again, frontal right there, parietal right here, decrease with age, but long range connection from frontal region to many downstream sensory motor and subcortical region increase with age. So that means when we grow older, when the frontal part of the brain is fully developed, it will be able to do their CEO task to control other regions of the brain in the temporal, in the parietal, in the occipital, insula, and so on. But for little kids, they might not have that fully developed, even though other parts of the brain develop, because if you recall, the high brain would be developed first, and then the midbrain, and then the forebrain, right? The order of development of the brain come from the basic vital sign in the back to the front. And also the concept that I would like you to take a look at here is synaptic pruning, which could be a good thing sometime if the connection, kind of like apoptosis, where the part that is not necessary will be get rid of, then the part that is necessary will keep growing. But it can also be bad if the type of activities or skills are not developed, it's going to prune away, right? So whatever is important, the brain will remember. What the brain deem as not important, it will just get rid of that information. So it's important to have that repetition and continue practice in order to keep the synaptic activity going for learning. And this one, you will get to see the DCCS, or dimensional change card slot, that I mentioned earlier, the blue rabbit, the red rabbit, and the blue boat and the red boat, right? So Mr. Philip right here will perform this assessment with his participant, and you get to see how it works.
Shape game, if I show you a boat like this, I want you to put it into this box. But if I show you a rabbit like this one, I want you to put it over here. Look, here's a red boat. Which box does that go in? Okay. Boats go here, rabbits go there in the shape game. Look, here is a blue rabbit. Which box does that go in? Okay. All right, now, you know what? We're going to play a new game. We're not going to play the shape game. We're going to play the color game. The color game, if I show you a blue one, you have to put it in this box. But if I show you a red one like that, I want you to put it over here, okay? All right, look at this. Here's a red boat. Which box does that go in the color game? Hey, you know what? Can you show me, where do the blue ones go in the color game? And where do the red ones go? So what about this blue rabbit? Which box does that go in?
All right, so that's what the dimensional change card slot looks like to assess children's cognitive flexibility. And it is important as well for us to make sure that they know basic, information about that. For example, shape, color, and things. So the experimenter will have to do some type of like pre-assessment first if children can recognize colors and shape before they perform this task. Okay, next slide. This is what it looks like. So they found that for children who can do the task successfully, their N2 is lower. This is the EEG measurement. When they perform the task, the children were assessed using EEG as well. So EEG looks really similar to FNIR, where participant would wear a cap, and then that cap will have electrodes that connect to the monitor to see the brain electric activity. And this is what they found, that the N2 is the lowest for participants who could do the task successfully. And N2 represent the 200 millisecond after representation of stimuli when they perform the task. Okay, here is what cognitive flexibility assessment looks like, right? Now you know the rabbit and the boat. And then cognitive flexibility refer to thinking outside of the box, as well as divergent thinking and creativity. So that's something that we want to make sure that we help our students develop. For this slide, I would like to point out the information in this last paragraph right here. In children, activity at the onset of each trial appeared to be driven by the activity from the previous trial. This carryover in neural activity may slow children's responses and lead them to make errors on trials in which the rule has changed. So this is the implication for teaching, and that is that the younger the kids, is the harder for them to do something new, right? They need more processing time to switch to a new thinking or frame of mind and or activity. So as a teacher, we might want to be mindful of this as well. So the discussion after all those presentation is this last bullet point. I think it's the key here. Preschool years, a period of time when neuroplasticity is high and executive function is undergoing rapid change. Executive functions during this period sets the stage for later developmental outcomes during middle childhood, such as academic success. Executive function during this period also predicts long-term developmental outcomes, such as socioeconomic status as well. So the key information here is that early childhood education is very important, right? And that is because that might have a long-lasting effect on their lives. Okay, and now I would like to explain critical periods, okay, in human brain development. What is critical period? So it is the period when the input is most impactful. Okay, whether it be audio type of input, visual type of input, or any other cognitive type of input, or even emotional type of input. It is the period when the brain is being primed for input. And if people have not been given input in vision, for example, during the critical period, it will be increasingly difficult for them to develop these skills later on in life. So for example, the binocular vision that we have, the critical period for that binocular vision was during the first year of life. So if a child was born with cataract and cannot see, one eye cannot see, and if no one detect that or take care of that right away, even though the cataract was taken care of later on after the first year, but the child will not be able to have binocular vision, okay, because the critical period was during that first year of life. And not only vision, but also hearing as well. For someone to become like really musical talented, they have to have the input like complex type of sound early on in their life, like between the first year to 7 years. If they have input complex type of audio stimuli right after 7 years old, they can still develop, but it's going to be kind of more challenging and very difficult for them. So this is telling us that especially, this different period of time is very important for different type of stimuli. So hearing, vision, language, and higher cognitive function. As you can see that higher cognitive function, the blue line here, will be developed later, right, until their teenage years. Okay, so after all of these things, you might wonder, so what are the 10 ways to develop student success? Okay, so taking in the information that we discussed earlier, I come up with this 10 bullet points, 10 approach to promote student success and learning. And the first one I have here is using games that can practice and strengthen executive functions. And those games can be taking turns type of game, board game, or anything that would require them to remember a set of rule, right? That is practicing working memory, and in playing with other people where they cannot expect the response from their peers, allow them to have theory of mind and cognitive flexibility to think outside the box. And then taking turns when they have to stop and wait for someone else's turn, that is inhibitory control. So the game and board game and other kind of game that require those things can help them improve executive function. And what I have here is also website where you guys can go in and take a look and play. But I'm just going to show you briefly here what it looks like. But it's the cognitive activity type of game. You can choose whether you're going to do memory game, math game, or cognitive flexibility game. I'm just going to try the memory game here. All right, so you have to remember. And then the tile is going to disappear. And then now you're going to have to recreate the pattern. Next, it's going to keep being more challenging. All right, remember. And now recreate it. Oops, there. Okay. And then you can keep trying or playing, right? This is something that you can play with on your own or with your student as well. All right, and the second one is Simon Says. Of course, this one, if you can guess, it is to assets or to not only assets, but to practice and train executive function. What core skill? Inhibition, right? Inhibition. So if you say, Simon Says, touch your elbow, and they're going to touch the elbow. If I say, touch your head, they're not going to touch their head. So they have to somewhat remember what the rules are, and they have to inhibit their behavior to touch or not touch based on the condition. And then the third one here is focus attention. Okay. So this one, like I said, that focus attention is key before any type of learning. And you can prime that attention for your kids by using either audio stimuli or visual stimuli. I know some teachers use white noise to trigger their children's alertness before learning. Or what I did just last week was that when I started to lose my students' attention, I just said, okay, let's pause here. And then I drew a target or like a circle on the board just right next to me. And then I told them to stare there for 10 seconds. Okay, so that will prime them to focus attention on target, which is me, right? I drew that on the board right next to me and I stand next to it. And then that seemed to work with me. And from different research, that can be something that you can try as well. Using metaphor and analogy. My MA was in linguistics, and I think this one is working really well when it comes to trying to make connection between something that they learn new, because how our brain works is that we learn from something that we have prior knowledge already, and we try to make connection to something that we just learned. And using metaphors such as the example would be if I want to teach them the concept of neurotransmitters and receptors, that there are specific type of receptors to bind with neurotransmitters to cause synaptic connection for neuron to fire, for example. If I want to tell them that, people who are not familiar with the terms might be like, what did you talk? So instead of saying neurotransmitter and receptors, I would just say that, okay, they work as a lock and key, right? You have to have specific type of neurotransmitter or the key to specific type of lock or receptor. So making that connection between something that they're familiar with and new terms would help them make connection between the two and make them remember better. And aerobic and resistance training is good, not only that it gives children goal-directed persistence, but exercising is good because it will help your body create BDNF, or brain-derived neurotrophic factor, which is a protein that help with neurogenesis and therefore help with learning. Okay. Also, researchers found that I think they did this in animal model with rodent, but I think there were also researchers that did the experiment on human participant as well. So they found that BDNF that is produced after exercising can help clear up the beta amyloid. Beta amyloid is a protein that is accumulated. They found that in patient with Alzheimer's disease. So you want to be able to get rid of toxic agent, just like beta amyloid, and BDNF can help with that. Space practice and repetition, okay, that would help them create that plasticity to form new knowledge and make it strong instead of pruning away. Okay? And then yoga and mindfulness, even micro rest interval, or an SDR is non-sleep deep rest. So for this one, I found in different type of research that, of course, sleeping is important, right? Adult 7 to 8 hours a day or a night, and nap is also important. But we know that some of our kids, they don't have enough time to sleep at home. They would have a hard time to sleep early, because that's just based on research. That's how teenage brain function, or their body, and how they regulate sleep-wake cycle. They tend to have later time to go to sleep, and then they would wake up later, right? But our school system is not like that at this moment. So how can we help them in our classroom? Instead of having them like totally fall asleep in class, even though you can have them like take a rest 5 minutes or 3 minutes, but if it's not like totally sleeping or taking a nap in class, you can just help them pause by just stop thinking about anything, close their eyes for 10 seconds. It depends on your class period, right? If you have longer period, you adjust it, whatever would be appropriate for your time and your student population. But what I'm saying is that even 10 seconds is good, right? For them to clear their mind without thinking about anything else, and then refocus again on the lesson. And then next would be theater. Of course, theater is great for executive function, because when we have to rehearse the line, we have to practice working memory. When we take turns saying the lines, that is inhibitory control, right? And working together with peers, that is practicing cognitive flexibility, and how you interpret the play, and how to do the different type of interpretation, dramatic interpretation based on the script. That is the flexibility, cognitive flexibility as well. And then chunking, I think, of course, this one we use as teachers, right? But I would like to also suggest this book as well. It's called The Magical Number 7 Plus or Minus 2 by George Miller. And what he says in this book is that basically our brain can handle limited information. We have limited capacity to remember and memorize things at one moment in time. So it can be 7 plus or minus only, but how we help children or even ourselves to learn to remember better is to chunk it. Instead of remembering it like 100, we can chunk it like 100 instead. And that would be a trick for memorizing. And then lastly here is, I cannot stress enough about stress elimination, because stress is an enemy of everything. They found that people who have a long period of stress, they see the atrophy or the the brain, the hippocampus area start to shrink. And also the HPA axis, or the hypothalamus pituitary adrenal axis, that would trigger the automatic response or sympathetic response. Our body will start to change, right? We have higher temperature and more heart rates, and blood pressure goes up, and all those things are not good for our body and brain. So avoid stress. And this one is an example that I use in my class. And if you have the PDF version with you, you can explore that later on. But this is kind of like an example of a full lesson plan with activity and rubric and everything that you can use that you can use to teach readers theater in your class. And that gears towards high school, actually, because I teach 11th and 12th grade. All right, so I think at this point, you guys probably kind of done listening to me. So we're going to pause here for 5 minutes. And then when we come back, we will get to try out some of the activities that I mentioned earlier. Okay, so let me put the timer on the screen for 5 minutes. And then we'll come back right after that. Right, welcome back. I just saw something in the chat. Can you guys hear me okay? Like, is it too soft or my voice? Is it?
No, the videos were soft, but I put
Oh,
links
oh,
to those videos in
oh.
the chat. So.
Okay, thank you so much. I just saw the chat later after the fact. Okay. Now will be workshop time. All right, it'll be fun. So this is gonna be the working memory assessment for children on missing span tasks. Okay, so again, working memory is how you operate over a few seconds, right? Taking the information and holding the information, as well as manipulate that information and having focused attention. So we're gonna try that out together. Okay, so I want you to either unmute or put it in the chat. What animal is missing?
Dog. Do we say it out?
Yeah, you can say it or you can put it in the chat either way.
Okay.
Yes, you're right. The little dog is missing. Okay, next. Which two are missing?
Oh, pepper and cucumber.
Okay, good, 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 good. All right. Which one is added? Or which are added, actually? There are more
Pineapple
than
and orange.
Okay,
Oh,
okay.
shucks.
You guys
Sorry, I'm
good.
slow at processing. My brain hasn't had its full cup of coffee yet.
All right. And this is kind of fun. It's something that you can try with your kids. And this is something that actually we're going to be doing next. Oops, no. Actually, before then, let's try some more tasks. Okay, let me explain first. Tower of London on the left here is the task that we use to assess planning and organizing skill. Okay. And I would like you to try to tell me verbally, or it's going to take a lot of typing in the chat. So you can just unmute and say it. Which are some of steps to make the right example here turn into the left example? So how do we change the right picture here to look like the left example? By moving one ball at a time. Okay, anyone want to try? Just say the sequence of how you're going to move the
You're
ball.
making the right one look like the left one.
Yes.
Does anybody else want to go? I'll go.
Okay, we can jump in a poll.
No, you
Uh,
go for it. You go for
okay.
it.
I would say take that blue ball and move it to the right peg first, and then take the red ball and move it to the same peg so it goes on top of the blue ball.
And
Oh, wait, stop. No, okay, wait, erase. I didn't see that. Okay, so visually, I didn't see that. Okay, the picture on
Okay.
the right, I didn't see that. I mean, I saw the third line, but I thought that was just part of the scheme.
Oh, okay. Okay, try
Okay.
again. Try again.
So, okay, go ahead. I've got a double. Okay, okay, so now that you've got,
Are we making
I think-
the right to look like the left?
Yes, yes.
Okay. Can I try?
Mhm.
go for it.
You move the green ball to the very right, the right stick, Then you
Mhm,
put the red ball onto the longest one on the left, then the blue one
mhm.
on top of that, and then you put the green one in the middle.
Okay, there you go. All right. So that's what it looks like, Tower of London. And it's kind of fun. You can keep practicing and you can kind of play that with your family or friends or students.
Mhm.
Okay, and so again, that is planning and organizing skills in executive function. And now I want you to try the right one here. It's called Stroop task. And Stroop task is to assess focus, attention, and inhibition. Okay, so the task is for you to say the color, not the word. Anyone want to try first?
What was that again?
Say the color, not the word.
Ah,
Okay, ready,
uh,
set, go.
who, me?
Oh, anyone who want
Oh.
to?
Red, blue, green, yellow, green, black, blue, red, yellow, black, yellow, blue, green, red, black.
Oh, pretty good. Yeah. Okay, who's next?
Is there a special order?
Oh, just read it like from left to right, like this, from top to bottom, but say the
Okay.
color, not the word.
Say the color. Oh, okay, this is a trick question, right? It's red, red, blue, green, yellow, green, black, blue, yellow, oh, blue, red, yellow, black, yellow, blue, green, red, black.
Yay, okay.
Gosh, I like this. This is
Great
good.
job. Okay. Deborah, you want to try?
Okay. My. Okay. Red, blue, green, yellow, green, black, blue, red, yellow, black, yellow, blue, green, red, black.
Yay! You guys are so great. Awesome. Now, you can find this online or you can even create your own. But the key thing to this is that if you want to try it out, this is for adult and you know why? Why it's not for little kids, like 1 to 3 years old. Anybody knows the reason?
Because that's mean.
That might be partly, but yeah, but what might be other reasons?
For 1 to 3-year-olds, is that what you said?
Yeah, how come this Stroop task is for only to assess adult inhibition, not little kids?
Because they can't read yet.
Okay,
So
because
then,
we are as adult, we are primed to read the letters or the word, and that's why it's difficult. For little kids, if they know the color, but if they not know how to read, they will have easier time compared to adult. Does that make sense?
yeah.
Okay, all right. Now, I'm glad you guys joined in. That was fun. Anyone want to try this with your family and friends?
Yeah, it's fun.
Oh, I'm doing this first thing Monday, period one.
All right. Okay. So now next one is an example of board game that you can apply in your content area. This one is something that I got from my son's school. They did this board game to practice the student's executive function. And again, board game, like I mentioned earlier, can practice all core skills, working memory, inhibitory control, and then cognitive flexibility. Okay, so you have this reference to come back to if you are interested in the future. Now, as part of the workshop time, I'm not sure, do we have 5 minutes enough for them to try doing this? Or since we have just like 4 of us, you guys want to try doing this activity, or you want to do that later? It's up to you, but let me explain first what you what is your task here? So my question here is that how would you design the working memory practice, right? This one is working memory or missing span task practice. How would you design it for your student population using your content area? So I think, is it Deborah? You teach music, right?
Yes.
So you can even use, I don't know what kind of music, like musical notes or musical instrument instead
Uh-huh.
of vegetable.
Uh-huh.
And then you can just create 2 slides. Like the first slide would be like you put a bunch of musical instruments on that slide, and then you would give them like 3 seconds. And then the second slide, you ask them, what's missing?
Uh-huh.
Or what's added? But what might be some other things that you can encourage to do apart from what's missing or what's added. So I have some suggestion here. You can change the position of the items. That will make it more difficult. That will make it more mean. So instead of like the dog disappear here, you can change them around. They would have a difficult time. But that will help them practice, because some students might need a little bit of challenge, right? They need to be challenged. So you can try that. Or you can use shadows of the items instead of the image, right? Like this, you can use shadow of it instead to make it more kind of interesting or more difficult. Oh, what might be some other ideas you think that you can apply in your teaching area or content? Any idea, Deborah or Diane?
So I teach science, so I'm thinking like for marine, you can put in different types of limu, seaweed, or you can do different types of vertebrates or invertebrates, depending on the phylum that we go over. Coral, biology, there's biology. I would just do something very elementary, even like put up letters. Use letters or numbers. I think it's just a matter of exercising their brain, which is kind of shut down since with COVID. Sorry, that was kind of, but just exercising their brain. But that's what I would do for my content. I might even throw in some vocabulary words.
Yeah. Oh my God, you guys are so great. You have a lot of ideas in mind already that you can start using right away upon coming back on Monday. Awesome. Thank you. So I don't think we have enough time to do this. I was thinking that I'm going to give you guys like 5 minutes to do this, but it's okay. You know what to do. Okay. You will do that on your own. And I appreciate that you share with me what your plan is. Okay. So the next slide here is a conclusion, because I think have about a couple of minutes left. The executive function, it's a whole lot of stuff, right? Like we talked about. But we have tools, and we have tools to assess, and we have tools for intervention and to practice with our students. And even though you have, younger kids or older kids, just remember that they are still developing all these key skills, and from this presentation, right, you know how to help them practice those skills. All right, now, this is my reference there. And then I think we have 2 minutes, yeah, Melissa, to address any questions you guys have about executive function or brain development and activity and assessment.
No, this is really awesome. What a fantastic presentation. So thank you.
Thank you. Thank you so much for attending this session. I was kind of afraid nobody's going to attend, but I'm glad that you guys are interested, and you guys are awesome participants, and you know exactly what you need to do to help your kids, and you have that plan in mind. Thank you.
Yeah, I think every teacher really should view your presentation, because it's very helpful.
Okay. Thank you.
Yeah,
I really
thank you.
appreciate that.
Yeah, this is a
Awesome.
treasure trove of information that, and to that point that teachers should actually understand, because it's helping me a lot. It's helped me a lot.
Okay.
Just rethinking how I approach things.
Mhm. Yeah, thank you so much. I am so honored and I am thankful for the opportunity to be able to get to know you, right? I hope I'll see you around sometime, somehow. You guys are on Oahu. I'm from the Big Island, but I would probably go there sometime for workshop and things. And thank you so much for attending our session. And I think, Melissa, are you going to put the survey in the chat for them for a chance to win a Target gift card?
They will get it to the email address that they registered
Okay.
with. Yes.
Okay.
Okay. Well, mahalo, Chayanee, and everyone for your participation. We hope you found this session helpful and made valuable connections. Special thanks again to our sponsors, Sacred Hearts Academy Honolulu and the Augustine Educational Foundation, for making this conference free for the past 10 years. Please help us complete the survey on the website iteach808.com so we can receive grant funding. I will put that in the chat. You will also receive a certificate of participation after completing the survey and automatically entered to win one of 10 $10 Target gift cards if you complete your survey by February 4th. The survey will also be sent to the email address that you registered with. Be sure to check your spam folder for any emails from iteach808hawaii@gmail.com. Thank you for being here today. Feel free to join our next session coming up and have a wonderful day.
Thank you.
Bye-bye.